All right, so find the exact equations for which the normal to the curve, which are parallel to the normals of the curve is parallel to the y-axis. Okay, if I'm not sure how the curve we already sketched last week already. So remember that when you try and sketch your parametric curve, you need to make sure you change your window setting. Okay, you have to know that you need to change your window setting. A lot of times students forget that need to change the window setting. Just remember this is very important. This costs a lot of marks every year. Millions of marks lost each year because of this. Okay, just remember that. So what we're gonna do is go to mode, change parametric, and then we are good to go. Hey, this is the same one. Oh, means I never used my GC ever since. Okay, good. So window T min is -1, T max is 3/2. Then just graph it. Oh, how come is it so weird? Let me check. Eh, correct. Oh, I did use it, so it's different. So come, how come it looks so different? Okay, this is 2 E T, and this will be T cubed minus T. Okay, then you just graph it. Now remember your GC's default. I'm just gonna write this down so that you'll remember. GC's default here is 0 to 2 pi. Okay, so just remember that. GC's default is 0 to 2 pi. So you change this from minus pi. So -1 to 1/5. So zoom out. You can zoom standard, but zoom standard would would change this to 0 to 2 pi again. So you just remember to change like that. Okay, so I usually would encourage students to just play around with the thing and get a nice shape out of this. So I will just try and get my nice shape. Ta-da! So max would be 3 minus 2. Okay, that's how I do it. Now remember I said that you try and always try and trace whether the extreme points. So like this is -1 and 3/2. So change to put -1 around here and see whether 3/2 is on the other side. Okay, so just remember that. I think I've done that quite a few times already, but you know. Okay, so we're going to talk about this graph here. You want a normal which is parallel to the y-axis. It's just a word play. So I think I better copy this graph down. Okay, because this is important. To illustrate it. So you don't have to sketch a graph for the first question, but if you want to understand, you just plot in your GC, right? Then you understand which is a normal, which is parallel to the y-axis. So you know that tangents are here, right? Tangents are here. If the normal are parallel to the y-axis, it means meaning to say that the tangent will be parallel to the x-axis. It's very annoying. It's just like, yeah, working backwards. So you will expect how many solutions? 2. From the GC, you must be able to tell that you are looking for 2 solutions. Okay, so this point here and this point here. Just remember that you need to find the solution here and here. Okay, so before even I start, I already know that there are 2 points there. So then you look whether it tallies with what they're asking. Find the exact equations so that I know it's sort of like correct really. Okay, usually that's what I'll do. I'll read the question and interpret it properly before I even start. So this case here would mean that this one is this is actually normal. M normal tends to infinity. This M tangent tends to 0 is equal to 0. Same thing. So in other words, we just find the tangent with 0. That's about it. So dx dt, find the tangent. So dx dt would be 2et. dy dt would be 3t squared minus 1. Okay, so dy dx would be dy dt divided by dx dt, which will give us 2et over 3t squared minus 1. Am I right? I hope no, the other way around. dy dt. dy dt. Yes, sorry. So this is 3t squared minus 1. Yeah. So this is 2et. Okay, great. This is correct. Okay, the other way around. Now, this is correct really. So once all you know is essentially normal is parallel to y-axis. Would deduce that the tangent is parallel to x-axis. Okay, which means that dy dx equals to 0. Okay, so this case here, what you need to do is that 3t squared minus 1 over 2et gives you 0. So 3t squared minus 1 equals 0. So t equals to 1/3 square root or minus 1/3 root. Okay, what do they want? They want the exact normal of the equation. So t, now, how do you check your answer? Using GC? Just plot in the t values. Like, understand that the parameters are invisible force behind the graph. It won't show on the Cartesian form, but it is the invisible force. So what you do is you just trace 1 over root 3, just put in like that, and hope for the best. It should be one of the, you see? So this is correct. So these are all exam techniques. Please know that these are all exam techniques. If you do not know, please know. Okay, but anyway, just know that. So this one, we know that this one will correspond to t. Maybe I should just put a grayish. This one is a t. Was it positive or negative? Yes, that's a negative one. Okay, this is a positive one. Okay, so that's it. I got that. Essentially, the equation of normal would be x equals to, just sub into the equation here, because each point will correspond to this formula here. So it's 2 e1 over root 3 and x equals to 2e minus 1 over root 3. That's about it. I think it's pretty okay. This is quite okay. Okay. Yeah. It's okay. I'm just gonna quickly go through this because we have two other things we need to cover. This part here, y is x, right? Just know that you start off with this one you need to know. This one you start off with t equals to, just now we say t equals to minus 1, right? This is t equals to minus 1, right? So you see t minus 1, you just increase to, this is where t equals to 3 over 2. Just know that the t's are the invisible force behind. So this is 3 over 2. How do I know that? I key in calculator. So I sub minus 1 inside. I know that, I start off with minus 1, negative 1. And it's there. Okay, so this is t equals to minus 1. All this you need to know. So when t equals to minus 1, when you sketch, right, just make sure that t equals to minus 1, what is this value here? So this value here will be 1 over e, right? When t is minus 1. So when t, 2 over e. Yeah, 2 over e. Oh yes, 2 over e. So this is 2 over e. This one here is 2, and this one here is, we did this last week. This last week where basically we find this by finding y is 0, t t square minus 1, 0. So t 0, minus 1 and 1. So this is t minus 1. This is t 0. This is t1. Okay, there you go. That's how we do it. I think this is pretty okay. Sketch the curve. I'm going to do the last one. Find the equation of the tangent C at the point, this one. Okay. Find the possible exact value of A such that the tangent cuts the y-axis at x equals to 1. Okay. At the point, okay, good. Okay. So, you know what's the question asking? No? Okay, so I'll just break down the question for you because I assume that you've already tried it at home. Each point here, this one will correspond to t equals to what? T equals A, very good. So the parameter here is when t equals to A, find the exact value of A. Tangent with cuts, find the equation of tangent in terms of A. That's what they're trying to say. Okay. So equation of tangent, we all know. Equation of tangent. So part equation, we just do one thing at a time. So I'm just doing part 1, finding equation of tangent first. Equation of tangent. So it's y minus y1 equals to m x minus x1, right? We all know that. It's very simple. So when t equals to A, x equals to 2EA, y equals to A cubed minus A, which is not surprising because that was the point we're given to us. Then dy dx is what? Is 3A squared minus 1 over 2EA. Okay, so this case here, so the equation of tangent will mean that you just replace this value inside here. This is x1, this one here. So equation of tangent will be y minus A cubed minus A equals to 3A squared minus 1 2EA x minus 2EA. All right. That's the equation of tangent. That's the equation of tangent. Oh, the answer is not given, huh? Yeah, but we're going to use the equation of tangent to find. This is the equation of tangent. You don't need to expand. You can just leave it like that. It's fine. But you want to expand also can. So I'll just. Actually, it's very ugly. So cancel. Yeah, there. You can just leave it. I don't think need to. Wow, this is very ugly. So actually, you can just leave it here like that. It's fine. It's fine. It's fine. Yeah. Now, remember what I said is this. If you, for parametric equation, if you want to find the points, you find the parameter. You want to find the coordinates, you find the parameter. You find the equation of tangent, you find a parameter. You find the normal, you find a parameter. You find area. Everything is parameter. Everything. So when you deduce this equation here, what we are looking at is at that juncture of depending on the A, if A equals to 1, I sub inside here, then the equation of tangent will just be this. Okay. How do you visualize it? I will visualize it for you using our favorite Desmos. It's so cool, man. I love Desmos. Desmos is for the win. See this. Okay, so how does it work? It looks like that. It's very cool one. So no. Here. So you get this case here. Why is it not loaded? Because I never save. Let me load for. I'm not sure why is it not loading. Sorry. There you go. This is okay. So you see here, how it works is like that. You need to understand that this is your equation of your what do you call it? Your tangent. So with different a, right? You see that with if a is 1.2, it will just take this point here. So if you were to just take this, let me just copy this down. This is a. This is a. Okay. So we already established last week, right, that with different a value, you will actually just trace it down, right? Correct, to the on the curve here. But because our parameter is restricted from -1 to 3/2, that's why we only take part of it. But if it's from -10 to 10, it will be the different part. Okay. So this case here, if once you get the equation of tangent, what happens is with different a, you just get the equation of tangent. Is that so cool? Right? So you just know that this will become like that. Okay. Now the next question is this. The question is find the possible exact value of a such that the tangent cuts the y-axis at number 1. Right? So in other words, right, if you have okay, the best way to illustrate is using decimals, obviously, right? So you want to cut at I don't even know what the question y equals to 1. So y equals to 1 would be here. Anyone? This is y equals to 1. Anyone dispute y equals to 1 at here? No, right? So I want to find the a value which will cut y equals to 1. Oh, actually I could find using decimals, which is a equals to 0. Easy peasy. But you can't do that in the exam. So the question now is how do you actually find for that? I think that's about it, right? There's no other point here, right? Yeah, there's no other point. So you want to find basically if you want to illustrate on your curve, right? It looks like that. You solve it like, oh sorry, let me just, what is this? Okay, can here you want to find the point. Let me just take a red color one. You want to find the point which cuts through here. Okay, here. So you need to find this point here. Okay, this point is very important. So what we're gonna do is essentially we're just gonna, for the last part will be sub x equals to 0 and y equals to 1 into the equation here, the equation of tangent. Okay, so that you get that ready. Once you get that, will be 1 minus a cube. My goodness, it looks so complicated. I do not know how to deal with this, man. So this is 0. Okay, then oh, that's pretty okay because you cancel away. So we are pretty okay here. So this is 3a squared minus 1, and this would be a cube minus 3a square plus 1. So minus 1 minus a 0. So this is 0a square minus 3a minus 1. Okay. Why do you reject the other one? That's a good question. Then I'll come back to that. So this one just use GC. Calculate out first. So minus 3, 1 minus 3 minus 1. That's a good question actually. So from GC you get this is 3.302 and the other one is minus 0.3027. And whereas this a here is 0. Okay, maybe I shouldn't, yeah. You always check back. So check back. They want the exact value, right? So you need to actually find, there's another point. It's a point. Okay, there's another, so you need to check. So you need to reject this one here. Okay, why? As a is minus 1, because parameter is only allowed from minus 1 to 3/2. Okay, that's why you reject. Minus 1 to 3/2. They just want to 3/2, right? So it means you need to proceed to find this exact value. So this exact value is when a goes to minus 3 over 2. So they want exact value, right? Find the equation, possible exact values. Okay? So means I actually sort of missed another one. I'm not sure which is the one which I missed out. Is there another one which cuts through? This is one. Oh, what else I had missed out? Oh, here, there are two. I see. Oh, very, very close. Oh, I see. Oh, you see that? Yeah, it's a scam. Sorry, because the concavity changes. That's why there are 2 points there. Oh, interesting. Okay, this is interesting. Okay, so there's another one slightly here, but anyway, you can only see it by solving it. So it's quite cool. Yeah, I hope you can relate what you see and what you're solving. If you can solve, you can relate that way, right? It's easier for you to solve. So we need to move on with exciting life by solving this exact value. This exact value is okay, right? We know how to find it. We just use our favorite quadratic function. Yeah. Do you know that this formula here in the O level, it was given in O level A Math, MF, but not the E Math MF. So it's another scam. Do you know that? You don't know that, right? You know that this formula here, right, is given in the A Math formula. It's in O level, right? But in E Math, it's not given. It's a scam. Yeah. I don't know, man. Okay, anyway. Plus minus. 9 square minus 9 square is 13, right? 13 over 2. So I need the one which is a negative one. The positive one cannot rejected. Reject. Okay, so hence 0 and equals to 3 minus 1. Okay, yeah, that's good. Question, people, please talk to me.